Welcome to my presentation. In this presentation, we shall see some more examples related to how to use the distribution rule to simplify variable expressions. So let us take an example here. In this example, we want to simplify an expression of this type: 3x minus 1 times 5. What if the term to be distributed is to the right side of the parenthesis? Very similar to what we did in the past. We can use the distribution rule. Let me write this in these different steps. Step number 1, 3x minus 1 times 5. We're going to take the term which is on the right hand side and then distribute it to every one of the terms inside the parenthesis, like that. So when we do that, this is the way we can write it out. 5 times 3x plus 5 times negative 1. So 5 times 3 is 15x, and then 5 times negative 1. Positive times negative is a negative. 5 times 1 is a 5. Therefore, this is where we want to leave it. The 15x minus 5 is the simplified form of this algebraic expression, and we have arrived at this by using the distribution rule. Okay, so let us see if we can expand it to some more examples. Let's say we want to simplify in this example the following expression: minus 2 times a squared plus 5a minus 4. Okay, so this time the term to be distributed is negative 2. So let us use the distribution rule, and then we're going to distribute the negative 2 to every one of the terms inside this set of parentheses. And when we do that, this is the way we can write it out: negative 2 times a squared plus negative 2 times positive 5a plus negative 2 times negative 4. Therefore, let's write this simplification process as step number 2. Negative 2 times a squared is negative 2a squared, like that. And then positive times negative is a negative. 2 times 5 is 10a. We have a variable a there. And then positive times negative is a negative. Negative times negative is a positive. 2 times 4 is 8. Therefore, this is our answer. Since the variable terms here are different, we have, in the first term we have an a squared, in the second one we have an a, and we do not have any variable terms for the last one, which we call it as a constant term. And since these three are different looking and non-similar terms, we are going to leave the answer as follows, and therefore that is the way we can simplify them using the distribution property. Let us look at one more example. In this example, we want to simplify 3 times negative x squared minus 6x plus 7. Let's say we have something of that type. In here, we want to be able to distribute this 3, which is outside of the parenthesis, to every one of the terms inside this parenthesis. So how can we write this? 3 times negative x squared plus 3 times negative 6 plus 3 times 7. So write it out that way. That way you will see that the term which is outside of the parenthesis is being distributed to every one of the terms, and then we want to also make sure that we are taking the sign into consideration. So we're going to use these rules. Positive times positive is always a positive. Positive times a negative quantity is always going to be a negative quantity. A negative quantity times a positive quantity will be a negative quantity, and a negative times a negative will always be a positive. So we will use this fundamental rule to be able to simplify the expressions as we go step by step. So therefore now, positive times negative is a negative. 3 times x squared is 3x squared. Therefore, negative 3x squared is what we're going to write there. Then positive 3 times negative 6x, positive times negative is a negative, 3 times 6 is 18, and the variable we have is x. And then positive 3 times positive 7, positive times positive is a positive, 3 times 7 is 21, and therefore this is our answer. There is nothing more to simplify here. X quad is different from x, is different from the constant number 21. Therefore they are non-similar terms, and therefore that is where we want to leave our answer. In my next presentation, we shall look at some more examples related to the distribution rule and how to simplify variable expressions.